Hello all, today we are going to discuss about MPG video processing. MPG video processing consists of three frames. First one intra frame, same as JPG. Second one predictive frame, and third one is bidirectional frame. Intra frame is nothing but typically about 12 frames between iframes. Predictive frame is nothing but encode from previous I or P reference frame, and bidirectional frame is nothing but encode from previous and the future I or P frames. These are all about the MPG frames. Then how we can selecting the I, P or B frame, that is change of scene should generate I frame, limit D and P frames between I frame and B frames are computationally intense. If type is of iframe, then sizes of 18K is compressed 7:1 ratio. Then for P frame, size of 6K is compressed as to 20:1 ratio, and for B frame 2.5K size is compressed up to 15:1 frame, and average 4.8K size is compressed up to 27:1. This is in this way we can selecting the I frames, B frames and P frames. Then we are discuss about iframe, that is MPG video iframe. It consists of intra-coded image. Iframes point of random access in MPG stream. Frame uses 8x8 blocks defined within the micro block, and no quantization table for all density coefficient, only quantization factor. This figure represents the video iframe, that is MPG video iframe. Then MPG video P frame. By using motion estimation method, a predictive coded frame require information of previous I frame and or previous P frame for encoding and decoding. For temporary redundancy, we determine last P or I frame that is the most similar to the block under consideration. This is all about the MPG video P frames. Then MPG video B frame, that is bidirectionally predictive coded frame. It consists of past reference, target and future reference. Applying DCT plus quantization plus RLE and Huffman codon, we get a video B frame. This figure represents the MPG video decoding process. Decoding is inverse of encoding. Then next topic is MPG video quantization. AC coefficients of B or P frames are usually large values. I frames have a smaller values. Adjust quantization. If the data rate increases over a threshold, then quantization enlarges step size, that is increases quantization factor Q. If the data rate is decreases below the threshold, then quantization decreases Q, that is a quantization factor. Then what is motion estimation? Motion estimation is the process of determining motion vectors that describe the transformation from one 2D image to another, usually from adjacent frame in a video sequence. It is an ill-posted problem as the motion is in 3 dimensions, but the images are a projection of the 3D scene onto a 2D plane. This is all about the motion estimation. In video editing, motion estimation is a type of video compression scheme. The motion estimation process is done by the coder to find the motion vector pointing to the best prediction macro block in a reference frame or field. Motion estimation examines the movement of the object in an image sequence to try to obtain a vector representing the estimated motion. Then what is a motion estimation algorithm? It consists of a previous frame, current frame and future frame. MPG motion compensated interpolation modes, that is block B is equal to block A, block B is equal to block C, and block B is nothing but the addition of block A plus block B by 2. This is the motion estimation algorithm. Most of the motion estimation algorithm have the assumptions like: first one, objects move in a translation in a plane that is parallel to the camera plane, that is the effect of the camera zoom and object rotations are not considered. Illumination is spatially and temporally uniform. Occlusion of one object by another uncovered background are neglected. There are two mainstream techniques of motion estimation, that is peel recursive algorithm, that is PRA, and block matching algorithm, that is BMA. PRAs are the iterative refining of motion estimation for individual pales by gradient method. BMAs assume that all the pales within the block has the same motion activity. The figure represents the two algorithms, that is a pale recursive algorithm, PRA, and block matching algorithm. The next topic is motion compensation. Motion compensation is an algorithm technique used to predict a frame in a video given the previous and or future frame by accounting for the motion of the camera and or objects in the video. It is employed in encoding of the video data for a video compression, for example in the generation of MPG2 files. This figure represents the macro block motion specification, that is consists of a three block, that is first, second and third. Predictive coding is widely used in a video transmission, especially for low bitrate coding. Typically, only the sum fraction of an image changes from frame to frame, allowing straightforward prediction from the previous frame. Motion compensation is used as a part of the predictive process. If an image sequence shows moving object, then their motion within the scene can be measured and the information used to predict the content of a frame later in the sequence. Motion compensation is based on the observation that much of the motion in images consists of a displacement of an element of the image. Motion compensation takes place microblock and compares it with all the possible macro blocks formed by making horizontal and vertical displacement in a small increments, typically half pixel. One of the most commonly used error measure is a mean absolute distortion, that is MAD, is given by the formula MAD xy is equal to 1 upon mn summation of I is equal to 1 to m summation of j is equal to 1 to n mod of f of x plus I comma y plus j minus p of x plus I plus dx comma y plus j plus dy, where x and y are the s coordinate of the upper left pixel of the m by n microblock being coded. Dx and dy are the displacement from the reference frames as shown in figure. These figure illustrate the basic of a motion compensated predictive coding. Each video frame is divided into non-overlapping rectangular regions, typically of size 4 by 4 to 16 by 16, called macro blocks. Each one macro block is shown in figure is of same size. The movement of each macro block with respect to its most likely position in the previous video frame called reference frame. The vector describes the motion by defining the horizontal and vertical displacement from the most likely position. The displacement typically are specified to the nearest pixel, 1 by 2 pixel or 1 by 4 pixel precision. If the sub-pixels precision is used, the prediction must be interpolated from the combining of the pixel in the reference frame. An encoded frame that is based on the previous frame is called as a predictive frame, that is P frame. One that is based on the subsequent frame is called as a bidirectional frame, that is B frame. B frame require compressed code stream to be recorded so that frames are presented to the decoder in the proper decoding sequence rather than the natural display order. As you might expect, motion estimation is the key component of motion compensation. During the motion estimation, the motion of an object is measured and encoded into the motion vector. The search for the best motion vector requires for that a criteria of optimality be defined. For example, motion vectors may be selected on the basis of maximum correlation or minimum error between macro block pixels and the predicted pixel from the chosen reference frame. We are already discussed about this formula. This figure A and B were taken from the same NASA video sequence. Figure B is identical to the figure A. Figure C is the difference between the two frames scaled to the full intensity range. Note that the difference is 0 in the area of the stationary space shuttle, but there are the significant difference in the remainder of the image due to the relative motion of the Earth. The standard deviation of the prediction residual in the figure C is 12.73 intensity level. The figure D shows a motion of compensated prediction residual with the much more standard deviation. The entropy was computed. If the prediction residual in the figure D is variable length coded, the resulting compression ratio is C is equal to 8 by 3.03 is equal to 2.63. To generate this prediction residual, we divided the figure B into non-overlapping 16 by 16 macro blocks and compared each macro block against every 16 by 16 region in figure A. The reference frame that tell within plus minus 16 pixel of the macro block position in B. The resulting displacement are the x and y component of the motion vector as shown in figure A. The white dots in the figure are the heads of the motion vectors. They indicate the upper left hand corner of the coded macro blocks. As you can see from the pattern of the vector, the predominant motion in the image is from the left to right. In the lower portion of the image, which correspond to the area of the space shuttle in the original image, there is no motion and therefore no motion vectors displaced. Macro blocks in this area are predicted from similarly located macro blocks in the reference frame. Because the motion vector in figure E are highly correlated, they can be variable length coded to reduce their storage and transmission requirements. This figure illustrates the increased prediction accuracy that is possible with the subpixel motion compensation. The figure A is repeated from the last figure C are included as a point reference. It shows the prediction error that results without motion compensation. The images in figure B and C and D are motion compensated prediction residual. They are based on the same two frames that were used in and computed with the macro block displacement to 1 by 2 and 1 by 4 pixel resolution. The most significant visual difference between the prediction residual in figure is the number and the size of the intensity peaks and valleys, their darkest and the largest area of intensity. The 1 by 4 pixel residual in figure D is the flattest of the four images with the fewest excursions to black or white. As would be expected, it has the narrowest histogram. The standard deviation of prediction residual in figure A to figure D is decreases as the motion vector precision increases from 12.7 to 4.44 and 3.8 pixel respectively. This figure shows the typical motion compensated video encoder. It exploits redundancy within the between adjacent video frame, motion uniformly between frames, and the physiovisual properties of the human visual system. We can think of the input to the encoder as the sequential macro blocks of video. For a color video, each macro block is composed of the luminance block and two chrominance block. Because the eye has a far less spatial acuity for the color than for the luminance. The chrominance block often are sampled at the half the horizontal and the vertical resolution of the luminance block. The grade elements in the figure parallel the transformation, quantization and the variable length coding operations of the JPG encoder. The principal difference is the input, which may be conventional macro block of the image data, or the difference between the conventional macro block and the production of it based on the previous and or subsequent video frame. The encoder includes an inverse quantizer and the inverse mapper, so that its prediction match those of the compensated decoder. Also, it is designed to produce compressed bit stream that match the capacity of the intended video channel. To accomplish this, the quantization parameters are adjusted by the rate controller as a function of occupancy of an output buffer. As the buffer becomes fuller, the quantization is made coarser so that fewer bits stream into the buffer. Let us considering the video compression example. The video opens with the 150 frame fade in from black, which include frame 21 and 44 as shown in figure, and concludes with the fade sequence containing frame 1595, 1609 and 1652 in the figure, followed by a final fade to black. There are also several abrupt screen changes like the changes involving frame 1303 and 1304 as shown in figure. An H.264 compressed version of the NASA video stored as the QuickTime file requires 44.56 MB of storage plus another 1.39 MB for the associated audio. The video quality is excellent. About 5 GB of the data would be needed to store the video frames as uncompressed full color images. It should be noted that the video contains sequences involving both the rotation and scale chain. Next topic is we are discuss about video compression. Video compression is the process of reducing the number of bits needed to represent a video without compromising its visual quality. The purpose of compression is to make the video occupy less space than the original file and to facilitate its transmission over the internet. Video compression is a crucial element of video editing and streaming and the data management. Loosey compression can be downgrade the quality of your video, while lossless compression will maintain the high quality at the expense of a file size. The popular video compression standard in the IP video surveillance market are MJPEG, MPG4 and H.264 are the popular video compression standard. The HDTV Grand Alliance standard has adopted the MPG2 video compression and transport stream standard in 1996. MPG2 support 4 resolution levels: low 352 by 240, main 720 by 480, high 1440 by 1152 and high 1920 by 1080. The MPG2 compressed video data rates are in the range of 3 to 100 Mbps. This figure represents every video compression works is group of picture, that is GOP, of which the first picture is a reference image and compressed with the JPG. This is all about the video compression. Then next topic is video compression standard. JPG, ISO and ITU-T for a compression of still image, moving JPG or MJPG, H.261, ITU-T, 5G, SGXV for audio visual service at a P by 64 kbps and MPG 1247 ISO IEC JTC1 SC29 WG11 is for compression of combined video and audio, while H.263 is used for video phone at a bitrate below 64 kbps, while JBIG ISO are the compression of the bi-level images and non-standardized technique, that is DVI is de facto standard from the Intel for storage compression and the real-time decompression, and the QuickTime is Macintosh are the video compression standard used for to compress the video. This is all about the MPG, motion estimation and video compression. Thank you guys.